Hello, everybody, and welcome to today's webinar session. We are delighted to be joined by Ido Kadim, Field CTO at NeuReality, who's going to be expertly guiding us through the topic today. Ido, welcome. How are you?
Great. Thanks for the intro, Tim.
No worries. We're really excited for the next session in this series with NeuReality and AI Accelerator Institute. Today, I believe you're tackling the critical challenge of maximizing AI accelerator capability. It's great to see loads of people joining. Ido, I'm going to hand you the stage. Enjoy. And folks, if you're listening, let us know where you're tuning in from. Drop your questions in the chat and Ido will get to them at the end. But Ido, over to you.
Thanks again, Tim. So hello, everyone. A couple of weeks ago, we came back from Supercomputing 24 in Atlanta and had a great show. And really, I wanted to share today some of the information that we shared there, including a live demo and hopefully, give you some more information to think about and invite you to engage with us. So the topic today is about unlocking the full potential of your GPUs and actually your XPUs. There's a problem that no one seems to be talking about. GPUs, which have become the foundation of AI computing, and again, really should probably be XPUs, are limited to about 50% utilization by the pre-existing server architectures. And that shouldn't be a surprise. Andy Grove, the iconic former CEO of Intel, coined the term software spiral. And it's only natural that hardware architectures will have to be updated when the software matures and vice versa. And we're at that point. But as a result of that low 50% utilization, or less than 50%, there's an impact on the actual adoption of AI, a lot of training, but not as much inference, not as much serving. And analysts report less than 25% of enterprises in production deployment of AI. And also billions of dollars of cloud and enterprise investment that go to waste by not taking advantage of the XPUs and infrastructure in general that they've purchased. So let's dive into this and understand why. So what you see on the right is real measurements that I will explain in a moment. But they look at two different systems. The top system on the left is an illustration of the traditional server architecture. It's served us very well for decades, and it actually has had accelerators supported in it for many years. We used to call them co-processors. But because of that architecture, when the balance of compute moves from the central processing unit to the XPUs, the system simply stops being efficient. And it suffers from very severe bottlenecks on the network interface, as well as in the serving side, due to a number of reasons, such as shared resources, I/O to host transitions, and others. What you see, the impact of that, you can see in the right. In the right side in the green line. When you start adding GPUs or XPUs incrementally, you quickly start losing efficiency. And in this case, running Meta's Llama 3 8 billion, there's a significant loss of utilization, even though the perception is, well, it's only just a model. Well, it turns out it's not. And so to overcome that, we built the NeuReality architecture with the NR1 at at the center. NR1 is built to serve XPUs and not as a general purpose central processing unit. It integrates the network interface with processing capabilities, heterogeneous computing resources, as well as a very efficient data path that enables us to take care of pre-processing and post-processing very, very efficiently, and therefore serve the XPUs and preserve a near 100% or effectively 100% utilization of the XPUs. Let's talk a little bit about how we measured those numbers. So, what the chart you saw on the previous slide was really generated by a real world scenario. It's not a benchmark. It's not synthetic. There are client pods that generate inference requests at a very high rate and really bombard those two systems with inference requests. On the bottom, you just see a traditional x86 server, well configured, I should say, with 8 XPUs. And on the top, in this case, an NR1S appliance with 10 XPUs. And that's what you saw on the and the results you saw on the previous page. The demo that we showed that supercomputing really focused on that top part on the NR1S and demonstrated the consistent utilization of the system. So before I go to the live demo, this is the dashboard that we'll be using on the demo. The demo represents up to 10 clients. We will trigger the demo in stages. So at first you'll see 10 clients, and you'll see that that client is served to the max capacity of the XPU that is in the system at about 400 tokens per second. And then we'll add 3 more, and you'll see that 4 of them still run at that same rate. And eventually we'll get to running all 10, and you'll see that they all maintain that same rate as you see here. So these are the left side. On the right side, you'll see the total aggregate tokens per second and the effective utilization on the bottom right. And with that, and with no further ado, I will invite you to join our CEO, Moshe Tanach, and O, to the live demo that we presented at Supercomputing. And if only I could get this to play.
Indeed.
Oh, there you go.
In this bench, we're going to show a performance, a live demo of our system running in the cloud, and we control it from here.
Tim, is there audio?
What you'll be able to see here is the linear scalability that our technology allows. So no matter whether you use a single GPU, 8 GPUs, or 800 GPUs, you will always be able to fully utilize them to 100% utilization, unlike existing systems that are basing on CPU-centric architecture. This is the configuration manager. We can select any cluster and any type of deployment, or we'll deploy Llama 3 8 billion parameters into our server and deploy containers into the clients, remote clients running in virtual machines, and running AI applications, sending AI requests to our server. Now we kick off the test, and we're waiting for all the servers to be deployed. We're going to see the green light when they're ready. And on a different screen, we can see the clients that are deployed. So we don't just give acceleration capabilities, we give the cloud ecosystem software that does all the Kubernetes-based management of the system, deploying the different containers for the application side, for the server side, and then triggering the test to start and sending AI requests from all clients at the same time. Yeah, now the test is starting. This is the monitoring dashboard that we can use. And now a single client was triggered, and in a few seconds we'll see the monitoring start to collect data from the client side, from the server side, and we'll be able to see the performance starting to pick up. Yeah, so now we can see that two AI accelerators are being stressed, and it's starting to pick up. And we saw a single one running at 400 tokens per second generated by the Llama 3 8 billion per ARM pipeline that was deployed. And even when we go to 4 of them, we still see 400, and the total amount that the server serves right now is almost 1,600, so 4 times. And this gives you the utilization, almost 99% utilization. So the important thing here is that a customer that deploy our technology or consume it on the cloud, he gets every bit of performance, every bit of throughput that he paid for. Today, when you look on the deployed GPUs in the world, they're roughly around 30–40% utilization worldwide. So imagine the amount of cost and energy that we're losing in the investment that we've done.
Okay, so this was the demo. Obviously, a somewhat shortened, abbreviated version. You're invited to go to the link at the bottom of the page to see the whole roughly 8-minute video in its fullness. But let's keep going. So when you think about this demo, let's talk about the implications. By regaining utilization, we can provide a significantly improved cost per serving, so cost per million tokens. Obviously, on the left, lower is better. Lower cost is always desired. The implications of this is really how many servers do you actually need in order to serve a given capacity. Right, so this has a very meaningful capex impact. And then on the right, performance per watt, and in this case, higher is better. Performance is always, we always want it to be higher. Again, we can provide very significant advantages in terms of performance per watt, thanks to regaining the utilization of the XPUs. This has significant OpEx implications, of course, because that translates to the cost of running the servers, or running the service. But in addition, it also means that you don't need as much power to get the same capacity out of your system. And so people who can't necessarily afford 150 kilowatt racks to serve their inference needs can actually get a lot of capacity at significant performance and significant performance density within their existing data centers. But that is not all. I think Moshe mentioned in the demo the aspects of ease of deployment. And with the NR1S, we provide what we think of as a appliance experience to help accelerate time to deployment of enterprise-ready applications. The challenge in this case is that, well, you know, you've built a prototype of the service, you've tested it and it works, and now you need to scale it. And when you want to scale it, you start running into the questions of what is the cost? Does the cost of the prototype of running the prototype at scale is that acceptable? For example, if you used a third-party service to serve your LLM needs over an API, that cost could balloon very quickly when you start serving it at scale. Additionally, then you need to integrate it into your MLOps and DevOps environment. And of course, you want to have fine-grained automatic scaling and control. And we address those by providing standard API access or implementation with our device. Providing a easy to deploy software stack to help port from any environment to the NR1S, and to basically to an owned model that whether it's hosted or on-prem. And then finally, a fully orchestrated platform with the appropriate plugins for Kubernetes and etc. Just to give you a sense of, on the left is what it would take in terms of just setting up and deploying a standard server, a general purpose server with XPUs, and all the manual steps that are needed to actually get to the point where you manage to get from a prototype to a production-ready deployment. You'll notice that many of the rows are empty on the right-hand side, and that's because you simply don't need to do them. They're all built into the device and into the setup of the device. And once you have the device, all you need to do is set up the Kubernetes cluster, leveraging the plugins that we provide, deploy preset pipelines, and you're off to the races. How do we do all of that? So we're proud to think of what we've built at the moment as the only agnostic infrastructure solution that is purpose-built for AI inference. We built an AI system architecture that makes AI inference more efficient and easier to deploy, as discussed here. We've provided a solution that integrates both compute and network infrastructure, and, as I said, accelerated data path to accomplish very high utilization levels of the infrastructure that you actually care about. And the appliance experience to make it easy to use. What you see on the right, obviously, is the chip that we built, which is the core of the technology. This is where the fundamental of the system architecture is built. The NR1S appliance, which can deploy up to 16 XPUs in a 4U form factor at a very efficient power envelope that fits any data center, and then a full AI inference software stack to enable the appliance experience, as I mentioned. We are actually shipping now to our first customers. One of our first customers is a cloud service provider called Cirascale, where we can offer access to the NR1S to help people start their migration. First instances leveraging the Qualcomm Cloud AI 100 Ultra accelerators as the XPU. And it is important to mention that any source implementation can be migrated to this, regardless of whether your prototype was developed on top of Qualcomm or any other XPU. So to wrap it up, what we deliver is an order of magnitude improvement in AI inference performance per dollar and performance per watt across all AI workloads, not just LLMs that I showed here, but also for computer vision, for ASR, for audio, for essentially any workload. It works with any GPU or AI accelerator. Any PCIe-based accelerator can be supported on our device. Faster and easier scale deployment, as I mentioned, with superior user experience. And our customers are cloud service providers that seek more efficient and scalable solutions, as especially they extend to offer inference as a service. as well as enterprises who choose NeuReality for their own deployments. And to join this family of customers that is growing now, please come to NeuReality.ai to learn more, or contact us to book a demo or a POC at the email address below, hello@NeuReality.ai. And finally, to connect with me, best place is always to start at LinkedIn and go from there to wherever. And with that, thank you very much, Tim. Let's go to Q&A.
Absolutely. Well, firstly, thank you, Ido. Super presentation, and yeah, very exciting to hear about NeuReality's customers and the work you're completing with them. Yeah, that's awesome to hear. There have been some nice questions throughout the presentation. Maybe we can start with Sam and Vishal, who are asking a similar question. Sam says, but isn't utilization workload dependent? If the workload is part sequential in nature, like LLM training, you cannot have full utilization. I know Heather has added some answers in the chat, but Ido, for sure, let's get your take on this as well.
Yes, I think that's a very fair question. I should say that the focus of the current generation of the NeuReality architecture is inference. The issues with training are different. These are two very different types of workloads and different focuses. The main difference to consider is where AI is the workload in training. AI is part of a business application and a pipeline, typically in inference. And whereas you can prepare the data meticulously and batch it very aggressively in training, you need more real-time or semi-real-time pre-processing of your source data in order to execute LLM-related tasks, or really any inference tasks. And so, yes, any workload would benefit in inference. However, it does indeed depend on the nature of the workload. Computer vision actually would gain probably the most advantage from this type of architecture, but LLMs, as well as demonstrated, will gain significant advantage. And I will also say the advantage could vary to some extent with XPUs because of the functionality of the XPUs themselves. The way we run is we choose which modules of an AI pipeline to run on which engine within our heterogeneous compute architecture, and we treat the XPU as one of those cluster, or one of that cluster of heterogeneous compute resources. And so mileage could vary to some extent, but very significant utilization advantages are given due to the root cause of the system architecture, of the outdated system architecture of CPU-centric history.
Super. Well, there we go, Sam, Vishal. Hopefully that answers your question. Feel free to ping back any follow-up questions you may have to Ido there. You kind of touched on it there, Ido, but AJ has asked, how does NeuReality compare to traditional CPU or GPU-based inference solutions?
Well, I think it compares, I think, number one, as shown, it is way more efficient. And I think that's the primary takeaway. And it's more efficient in two ways. One, in performance. You gain utilization of your system, and by gaining utilization of your system, you improve cost of serving per dollar. I mean, performance or cost of serving, I should say. And you can gain more within an existing data center infrastructure. So easier to deploy in a physical sense. And as well, it is easier to deploy from a software programming standpoint in that transition from development to scale deployment.
Super. The next question is, how do you see the evolution of AI-centric architectures playing out? And what is NeuReality building next?
Well, I think I'll say a couple of things. One, obviously, this is the first generation of more to come. More performance, more use cases. Some were mentioned here as areas where this specific issue is less visible. We will expand and address. Our immediate priority is to bring this value to deploying customers now.
Fantastic. Perfect answer, I think. Folks, if there are any more questions, drop them in the chat by Ido. If not, maybe you can remind people where they can find yourself and NeuReality to follow up.
So I think before I do that, I would love to hear from the audience, from people's experiences. Are other people seeing these challenges? The two challenges that I really mentioned. One is of lower than desired utilization of your infrastructure, and secondly, the complexity of going from, or the challenge overall of going from prototype to scale deployment of AI inference. And with that in mind, I'll perhaps remind people, please do come to NeuReality.ai to learn more, or send an email to hello@NeuReality.ai to ask us to engage with you for demos or POC. We'd love to engage and again bring this value to more customers.
Well, we've had one response. AJ says yes, production journey, the journey to production, that challenge is the greatest. Yeah, for sure. It seems
Thank you, AJ.
Common theme over the past few months. Certainly, when we've been having this conversation, Ido, and throughout the summits that we've been hosting, that challenge is a huge one. Folks, if there are no more questions, Ido, maybe you want to wrap up with some closing remarks. But yeah, what a super session.
Yes, I think I'll go back to I wanted to expose to all of you this challenge that the world doesn't seem to be talking about, but is very real, of low utilization. And I think the complement of that is slower than expected adoption of AI because of the complexities that are associated with it and the costs. And we are here to help with that transition to deployment. There's no doubt that AI inference will be a huge consumer of infrastructure in the coming years. All the investment in training must turn into business value, and by serving is where the business value is created. We read about these new use cases every day, and it's time for them to go to production, and we're here to help. Thank you all. Perfect.
Wonderful way to wrap up. Ido, thank you so much for your time. Thank you to all the NeuReality team, and thank you everyone for joining us. Sam, AJ, Cindy, Greg, Mark, there's people chipping in the chat. Thank you for joining the conversation there, and thanks to everybody that has been watching. We'll be back very soon, I'm sure, with further discussion on this topic and further contributions from Ido and his team. So thank you everybody for joining. Have a wonderful evening or afternoon, wherever you are, and we'll see you soon.